Hey guys, so today I'm going to be talking about how to use a risk-based approach in your testing efforts, and actually kind of all of your development efforts from planning your releases to actually deploying to production. So before I do that, let's see, we're going, awesome. A little bit about myself. For the past 12 years, I've worked in some form or fashion in software development. I started off in video game development, where I did manual testing as well as level design and scripting, audio work. And I moved into the test automation realm about 4 years ago when I started at O'Reilly Auto Parts. I love automating things. I like reducing the time it takes to do repetitive tests. So like I automate everything in my house. I think I might have a little bit of an addiction. My lights turn on and off automatically for me when I leave. My coffee starts for me in the morning, everything like that. I'm also a longtime musician, so I like to write audio plugins. I've automated light shows for bands that I've been in. So that's just a little bit about me personally. So I'll be talking about what is risk-based development and testing, kind of what the benefits are, what are different types of risks, how to reduce these risks with automation, setting up quality gates to help reduce what I call quality debt. Just like technical debt, you can have quality debt if you're releasing a lot of buggy releases. And then how to provide feedback and metrics and continuous evaluation of your process to make sure you're testing appropriately, fastly, and efficiently. So what is risk-based testing? It's basically a way to reduce the risk of your products that you release. You can't eliminate risk. There's always going to be a risk with software. There's no such thing as bug-free software. So what you want to do is be able to identify high-risk areas of your application and plan for those. Develop those first, test those first. You can use it for guiding your manual testing efforts as well as your automated testing efforts. It helps your software be better. It helps your release time be faster. And it really gives a better, kind of overview of what your applications and your processes and testing looks like. So just more of the benefits is, it improves your productivity because you're focusing on the really important parts of your application first. Improves your quality because you're catching bugs sooner in your software development lifecycle. It allows you to provide really good, clear metrics for your test coverages. It helps reduce your redundancy of tests, and it speeds up your release cycle dramatically. So some of the types of risk, you can have project risks and product risks. So project risks are risks that are going to put your project deadline, might make it push out, might make it not get completed at all. So there can be organizational risks. Those include things like skills, training, your resources, communication, making sure you have the right type of tools that you need available. There can be technical risks, so bad business requirements, bad environments, low code quality or data, or low quality tests. Or you might have third-party services that are down, or your project might not integrate or interrupt with other parts of your business like it should. And then there are product risks. So those are bad builds that are failure prone. There's potential to cause harm to your company, either financial or legal. The software might just be bad software, have bad UX. It's not good for your users. They don't like using it. It doesn't perform what it's supposed to do. You might have bad data integrity or security or quality of your data. Or you might just have software that doesn't meet the business requirements. So those are some of the kind of high-level types of different risks. So you can take those risks and you can you apply a ranking to them. So 5 different levels, spelling, minor UI issues, something's the wrong shade of green. That's not really going to cause a huge issue with your software. Whereas up to like a level 5 risk, if your app crashes or there's loss of functionality, that is a really high, that's a really bad risk for your application. So as you're going through and you're creating features or you're creating opening bugs, you want to be assigning these a risk level as you're doing that. The important part of that is you can see like where your high levels of risk are in your application. So that's what you should be developing first, and that's what you should be testing first and automating first, and be running these tests with every release that you do. And so once you've rated all of them, you can kind of average them out to basically kind of like low, medium, high risk, kind of like a severity. If you open an issue, if it's a critical bug or whatever, it's probably going to be high risk. Doesn't necessarily always go to 1-to-1. So once you have these ratings, you can take and basically, as you're planning your releases, you want your dev teams to be developing these high risk areas first. And then you also want to be testing those first. So you have a huge list of backlog issues, and you're doing a bug fix release. So let's pick all of these high-risk areas first, automate them if you can first, test them first, develop them first. And so that's kind of how you should be building your test plans. It's like the kind of theme this year has been, everything is fastly moving into digital disruption. We don't have time to test every little thing. So if you're planning your testing cycle, test areas that are going to potentially cause the app to crash, not that a screen has the right color on it first. Obviously, if you can get to all that, that's the ideal world, but projects and releases move fast, so you may not have time to test everything. And so that's the whole point here is basically to just kind of try to reduce your risk. So using test automation and build automation to reduce your risk. So I like to what I call quality gates in your continuous integration or continuous deployment environments. So by doing these quality gates, which I'll go more detail about what a quality gate is later, it reduces time to feedback to your developers, to your stakeholders, to your product owners. It helps to continually reevaluate your coverage, make sure you're testing the right things. If you start seeing high-risk bugs happen in an area in an application, that probably means you don't have good test coverage there. So if you continue to see a lot of high-risk bugs open, you need to know that you need to go evaluate and make sure you're running tests in that area. And then you can also do like staggered testing types. Again, I'll go in a little bit more detail here in a minute. But the whole idea is to reduce your product and your project risks all at the same time. So kind of an example that we just did at O'Reilly not too long ago, our point of sale, we dramatically changed how you actually access the system. We changed the way our sign-in screen works and everything like that. So that was a really high-risk area to be touching in the application. And so we had to rely heavily on our automation efforts to do a huge set of regression tests once you're in our point of sale. So the first thing we did by having all these ratings and prioritizing and grouping our tests accurately, we're able to determine automated tests that are no longer valid and would just definitely not run anymore. So we're able to pull those out and then start revamping them as needed. We did this alongside of our developers where we actually created our own branch along with their feature branch. And so by the time we got the first release of the new point of sale with the changed login screen, we had all of our tests able to be ran again. So that's kind of the whole mindset that you really should be taking is reducing your risk. So we were able to not only reduce the product risk by making sure we still had good test coverage, we reduced the project risk by making sure we were automating up front so that we could still run our tests as soon as we got the first release. So the day one, we were able to hit the ground running, testing and still running our full suite of automated tests. So the main important thing that I'm talking about, and this is huge for web applications, is quality gates. So you can kind of see this little diagram here. There are different steps in here. So at build time, if you're using something like Jenkins or some other CI environment, you pull your code, start your testing even at the code level. Use something like Sonar that has quality threshold profiles for your actual code quality. If there's too many obvious errors in the code, don't even make the build because that's going to put the project at risk because you're going to have a bad build that you're going to have to duplicate your testing effort later. So you build the application, you do some light integration tests, making sure the application is up and running. And then depending on the issues that are in the test, you want to use things like Jira to put components on your test assets or some type of test tracking or test management software so that you know which tests you need to be running for, say, like a development release in the development environment. You don't probably want to run your entire regression test for every build in the development environment. But if you know that the issues that they're fixing can get pulled in through something like Crucible or Fisheye, you can know that you then need to pull these tests in to run to make sure their changes didn't break existing functionality for each development release. Then you can stagger down, if it's in the test environment, you can start running your UI smoke tests, regression tests, and then do like some security, performance test, API testing. All of these kind of come down to different types of quality gates. So a little more detail. So code quality. You want to do several different checks for your code quality, continuous monitoring of overall code quality. You want to make sure that code reviews are happening. You're doing unit tests. You want to set up good thresholds with whatever types of tools you're using so you know what's acceptable amount of risk of your code getting put into a build, what's not acceptable, and making sure that those are staggered from development, testing, and production environments. You might have different profiles for a development environment as opposed to testing and production because that's where, things are more volatile. It's where you're trying new approaches and everything like that. And then integration tests would be the next quality gate that you'd want to go to. You want to make sure your expected services are up and running, your application is live and responding, and then you want to start doing some light API tests to verify that the backend is actually working and behaving correctly. If your backend isn't giving you the right data that you expect, there's really no point in testing the UI because it's going to fail there as well. So it's another quality gate that it has to pass before it can go to the next part of your build or testing process and pipeline. And you also want to make sure that any extraneous services that your application relies on are up and running too. If they're not, then there's no point in testing that area of the application. If they're down, you need to wait till you can get with your vendor to get them up and running again. And so after you've kind of done that, you have your integration tests, your code quality checks out. This is where you want to start running like your UI and maybe your security and performance tests. So you want to do like high-level functional smoke tests to make sure like the happy path areas of your application work. Make sure that all those tests should always pass. And once you have that kind of warm fuzzy that the main happy paths of your application are working, then you can move on to doing your full regression tests. You can start doing security tests. So you want to be running like API security tests, scans, so on and so forth, and even start doing some like light load testing. If you have a good baseline, you know what's acceptable for your response times in your application. Make sure a new build doesn't break these because if you don't test that now, it's going to get out in production where there's going to be a huge load, and then you're going to have really problems. So that's another high product risk for whatever your application is. And so by doing all this, you kind of reduce your time to feedback. It's a constant loop of feedback. You create, like I said, you have your high-level automated smoke tests. You focus your efforts on really high-risk areas of the application and make sure you're automating appropriately. So like I said, if you don't want to have automated tests that verify something is necessarily the correct color. That's very subjective. That's easily breakable, but it doesn't really have a high risk as far as impacting your users or impacting your business. And also, like I said, for our point of sale release, what we did was we were automating alongside development. As soon as they finished up a new part or new feature for the next release, we would start automating tests on it with it. So day one in the test environment, we're running a full set of tests that have been developed alongside of the features that are going into the application. And so by being able to do all this, you catch bugs earlier, you get feedback to your developers earlier, you get feedback to your stakeholders, your project managers earlier. And the more you can do that, the faster you can do that, the better, because in that there's less risk of bugs getting through your testing process later on. So this kind of goes more back into what to and what not to automate as far as tests. Anything that has to do with like data, customer data, sales records, things like that, really high risk areas, you definitely want to be automating those. You want to be running those as often as you can because those have the biggest potential to hurt your customers or your business. And security, cybersecurity is huge. So you want to make sure, Ready API, for example, you can be writing functional data-driven API tests and immediately use those also as security tests with little to no extra effort. So it's a no-brainer to make sure that you're automating that as well and running it with each release. If you're quickly deploying and pushing new updates to your applications all the time, some people do week releases, some people do daily releases, some people release builds every hour. So the more that you can shove in there in the shorter amount of time to just help reduce the risk, the better. And so that kind of comes down to don't raise your project risk by automating stuff that is going to be subjective or could be easily broken by a small change in the application, because then you just have to spend the time figuring out why the test failed, go update your asset, and then wash and repeat. So if it's a new application, it's a really fast-changing area of the application, hold off on automating it at first, because you're going to spend more time trying to chase down false failures than you are actually reducing the risk of your product. And then, basically just make sure you're getting, the most return on your effort for what tests you're automating. So at the same time, you also want to reduce your automation risk. So last year I talked about building a really reliable and extensive framework for your automated tests. I won't go into super technical detail, but if people have questions, I'm more than happy to talk more about that after this. So you want to make sure like all of your script code, all of your tests are modular and can be pulled in or out and used across multiple projects. You want to make sure you have different types of tests covering, happy path tests, doing some edge case tests. You want to be able to report good metrics off your test. So what we do at O'Reilly, we use a plugin for Jira called TestFlow. It's very similar to Zephyr. I wish I would have known SmartBear was going to be acquiring them, because I would have gone with that instead. But so all of our tests are tracked through Jira. Every time we have a new release, our frameworks actually go to Jira, pull based on component and status of an issue. So if we've automated a test, that test case has a status of automated test. So at runtime, we never run the same set of tests twice. It's based on what we have automated and what we need to run for that release. So it'll pull that test list down and then report back metrics. So how often does areas of the application fail in our automated tests? If it's a really high area, okay, that's a high risk area. This area is problem prone. We need to make sure we keep our coverage there. Have we ran 200 tests over the past year in this area of the application and they have never failed? We can start scaling that back. So to reduce that time to feedback, maybe not do as many edge cases and just kind of keep on the happy path until there is a change in that area of the application, which you would know based on the components coming in from the build, then we can pull those tests back into our suite. But this is all done at runtime, and it's really good to have the metrics for it so you can see where your risks are, where things are failing, where they're not failing. If you're changing an area of your application and you've ran, like I said, you've ran several tests that are passing and you're rating those features and issues as high risk, but they never fail, then that's probably not as high risk as you think it is. So you always have to go, you have to keep continually evaluating. And that's where the metrics really come into hand. So you want to keep the number of tests that you ran, which releases they ran against, how often you've ran them, when they've failed, what the reasons for failure are, and the failure history. So we link all of our test cases. If we find a bug while during an automated regression run, any bugs that are open are linked back to that test case, so we know, hey, this next build has a fix for this bug. We need to make sure this test runs again. And then we also try to differentiate between what types of bugs they are. So is it an environment issue? So if it's an environment issue, that's a project risk, not necessarily a product risk. If it's data or applications, it's definitely a product risk. Or if it could just be a bad test case for testing inappropriately. So you keep all these metrics, you keep a history of what you're running, and then you can pick and choose what you want to run at any given time based off what's going into the release. And so as you're capturing these metrics, you're reporting these metrics, you want to constantly evaluate how you're building your test list. If you're making sure you're rating things at appropriate risk levels. And so you can do this by doing all this, you end up increasing your overall coverage of your application, but you're not increasing the time it takes to test your application. So it's kind of a balance of what is high risk and what needs to be updated and what is low risk that can maybe be ran for this particular release. And so basically risk-based testing is all about minimizing risk, not eliminating it entirely. You use your ratings to kind of plan your development and your testing. Quality gates are huge in your build processes. It reduces the time to feedback and reduces your time to feedback and reduces your quality debt. And then metrics are good to report where the areas of your applications are high risk versus low risk. And then to kind of make all of this work together, you have to have a really good, solid set of automated tests and frameworks, and they must be reliable and robust. So yeah, that's kind of risk-based testing in a nutshell.